What was the cognitive revolution? The cognitive revolution occurred around 1960, and this is where research in psychology began to focus again on the mind, studying aspects of the human mind. Between 1910 and around 1960, the focus was on a very different topic, that of observable behavior. The field of psychology was dominated by behaviorism, so research topics on the mind were neglected. Prior to 1910, there were the structuralists and the functionalists who were focused on understanding aspects of the human mind. So, after 1960, new researchers began to focus specifically on mental states, understanding human memory, human thinking, human problem solving, and even language. We'll see some examples where research done in the late 1960s actually follows up or attempts to replicate research that was done in the late 1800s. So the cognitive revolution involved rediscovering some of the old forgotten research on mental states. Researchers came to rely on the computer metaphor to generate ideas for how to go about studying the mind and conceiving of the parts of the mind, how the processes work. So, in this diagram you see what might be the basic components of a computer at that time: input and output with a processor in the middle and some capacity for memory storage. By this point in history, there were lots of computers, generally owned by governments and large institutions. They were as large as entire rooms. While researchers in the 1960s were using the computer metaphor to understand the human mind, back in the 1940s, when modern-day computers were being designed, it was the human mind that inspired the design for the basic components of a computer. John von Neumann is given credit for designing the modern computer, the diagram you see on this slide. Some have said that others helped out and they failed to get credit for their contributions. Nevertheless, John von Neumann was a very interesting mathematician, physicist, and computer scientist, born in Hungary and then a professor in New Jersey. The story goes that the design for the modern computer was based on how the mind functioned, that there is input to the mind. Let's say you're given a math problem, and then you have the control unit and the arithmetic unit and a memory storage unit that's going to process that information, and then an output unit where the answer can be spoken or written. Early cognitive models attempted to break down a particular process or task into a series of stages that would be occurring one at a time. Such models generally were viewed as serial processing models, one stage at a time, each with non-overlapping processing occurring. For example, stage 1 might be perceiving a math problem, 5 plus 4, and stage 2 would be computing that math problem, 5 plus 4 equals 9. And then the last stage would be generating the written output of the answer, 5 plus 4 equals 9. One of the most intriguing proposals about the human mind was proposed by Jerry Fodor, an American philosopher. He proposed that the mind consists of functionally independent modules, and each module is hardwired, meaning present from birth. It's domain-specific, focused on a particular kind of processing. It's fast, automatic, and stimulus-driven, informationally encapsulated, meaning that the work that the module does is not done by other modules, and that there's really no processing of that material simultaneously by multiple modules. One module does its own thing. The modularity of the mind continues to be debated among researchers. Many believe that it's an oversimplification. However, there are still some individuals who believe that for certain kinds of processing, there may be specialized modules of the mind. We see serial non-overlapping stages in the early broadband model of attention. The model aimed to explain how all the information that we are exposed to, either visually or auditorily, is entered into our sensory systems, but not all of it is then selected for deeper, more thorough processing. So in the middle yellow box, there's a selective filter, and that filter serves to determine which information will be processed at the higher levels. An important aspect of the model was that information that did not make it past the yellow box of the selective filter did not get further processing. So good evidence against this model would be to find cases where something is not paid attention to early on, but later on one can show that there's awareness of that information that was not paid attention to. Has this ever happened to you? You're at a social gathering and there's a lot of people around and a lot of noise, so you are focused on the conversation with your small group in the corner and you're trying to ignore everything else that's going on. But after a while you suddenly hear your name from across the room, over there in a conversation where you were trying to ignore all of that noise. That situation has been called the cocktail party effect, that even though you are ignoring information, if it's relevant to you, such as your name, it actually can break through to have you pay attention to it. So the cocktail party effect is evidence against the Broadbent theory of attention. Something that gets filtered out initially actually can still be processed at some low level and then come to be paid attention to later. So Broadbent's model can't be correct. So Broadbent's model was found to be incorrect, but you see that it serves as a huge inspiration for the models that were to follow. Anne Treisman proposed the attenuation model of attention, and as you see in this diagram, instead of a selection filter in the middle, you now have an attenuating filter, meaning that you reduce your processing of some streams of information while others might be processed at 100%. So beyond the attenuation filter, both messages can be passed on for further processing, the one you're paying attention to and the one you're ignoring. In a later model, the Deutsch-Norman selection model, it was proposed that it is the meaning of the ignored information that can break through to consciousness, and therefore it can be selected on the basis of what does it mean? Is it related to something that's important to you? Because that it's based on the meaning of the message being selected, it's viewed as a late selection model occurring quite late in the processing chain of events. While early models in cognitive psychology tended to have serial stages of processing, more recently, models that involve parallel stages of processing have become popular, but you can still find models that have both. Some aspects of the processing will occur serially, while other aspects of the processing will occur in parallel or at the same time. That's all for now.